Welcome back to the Deep Dive. Today, we're going to try to unpack a really interesting tool from the world of econometrics. It's called matching.
Mm,
You can think of it kind of like a detective's toolkit for uncovering clues in messy real-world data, especially when we're trying to figure out, the impact of something,
hmm
but we can't actually run a perfect experiment.
Yeah, that's a great way to put it. Matching is all about making sense of those situations where things aren't, neatly controlled, like when we're trying to study the effects of a government policy or a program,
Right.
and we can't just randomly assign people to different groups.
Yeah, like in a clinical trial, which would be
Exactly.
the ideal.
Right.
So our case today actually involves a hypothetical scenario in a developing country where, let's say, you have a corrupt government
Mm-hmm.
and they're handing out grants to health clinics. But here's the catch. These grants aren't necessarily awarded based on, actual need.
Right.
They're based on political alignment.
Yeah. Exactly.
Yeah.
Which makes things really tricky because we need to figure out, okay, are improvements in health outcomes due to the grant itself?
Right.
Or is it simply because the clinics that support the current regime were already doing better for other reasons unrelated to the grant?
Yeah. So it's like we're trying to compare apples and oranges.
It is.
Okay, so how does this idea of matching actually help us kind of solve this puzzle?
Mm-hmm.
From what I understand, we want to find clinics that are very similar
Yes.
in terms of their political alignment.
Mm-hmm.
Some that got the grant, some that didn't, and then compare their outcomes.
That's exactly it.
Yeah.
You've got the main idea. By creating these matched groups,
Uh-huh.
we're essentially trying to mimic that randomized controlled trial. Even though we're dealing with observational data,
Right.
we can then compare these groups to try to isolate the impact of the grant itself.
Okay.
Now, there are two main approaches we can take. We can either create a matched sample,
Okay.
where we pair up similar clinics and drop the rest, or we can use weighting techniques to make the groups statistically comparable.
Okay. Now, wouldn't it be easier to just, control for political ideology in a regression?
Oh, that's a great question.
Yeah.
And you absolutely could try that.
We've talked about regression before on the show.
We have.
It seems like a very straightforward way.
Yeah, but matching has a unique advantage.
Okay.
It doesn't force us to assume a specific relationship
Uh-huh.
between political ideology and health outcomes.
Okay.
For instance, maybe that relationship isn't perfectly linear.
Right.
Maybe it's more complex. Maybe it's curved.
Okay.
Matching gives us that flexibility.
So it's kind of like a safety net to make sure we're not making assumptions about the data that might not be true.
Exactly. It prevents us from imposing a structure
Right.
that might not actually exist in the real world.
Gotcha. So this flexibility makes matching particularly useful when we're dealing with really complex relationships.
Yeah, especially when our data is limited,
Right.
which is often the case in real-world studies.
Okay, this is starting to make sense, but I'm really curious to see how matching actually works in practice. Can we walk through some examples?
Absolutely. Let's start with the simplest type.
Okay.
It's called exact matching.
Right.
So imagine we could find pairs of clinics
Uh-huh.
that are identical in terms of their political ideology.
Right.
One that received the grant and one that didn't.
Okay, now wouldn't we end up throwing out a lot of data if we can't find those perfect matches?
That's the trade-off with exact matching.
Okay.
It gives us a really clean comparison,
Uh-huh.
but it can reduce the amount of data we're actually able to use.
Right.
Now let's make it even simpler. Let's say political alignment is binary.
Okay.
You either support the regime or you don't.
Right.
In that case, we could just pair up clinics with the same political stance.
So one clinic that got the grant and one that didn't, but both with the same political stance.
Exactly.
Okay,
That's the idea.
that makes sense. How do we actually do this, though, in our analysis?
So there's this handy tool in R. It's called the Matchit package.
Okay.
And it has a function called Matchit.
Right.
And this function helps us create these matched data sets.
Okay.
We would feed the function information about whether a clinic received the grant
Mm-hmm.
and their political ideology, and it would find all the perfect matches based on our criteria.
Okay, so we would lose any clinics that didn't have an exact match
Right.
based on political ideology.
Uh-huh.
It seems like this could be a problem when we're dealing with more nuanced data,
Yes.
where political ideology isn't just a yes or no, but more of a spectrum.
You're exactly right.
Right.
And that brings us to the next type of matching.
Right.
It's called distance matching.
Distance matching. So instead of needing those identical matches,
Yeah.
we're now looking for clinics that are just close enough
Exactly.
in terms of their political leanings.
Precisely. Distance matching uses the concept of distance
Okay.
or difference between the values of the matching variable. So we want to find the control unit that's closest to the treated unit.
In terms of political ideology.
I'm picturing this like measuring the distance between 2 points on a map. The closer the points, the better the match.
That's a great way to visualize it.
But what happens if we're comparing variables that are measured in different units? Like GDP, which is measured in dollars,
Right.
and unemployment rate, which is a percentage.
Yeah, you bring up a crucial point.
Wouldn't that skew our results?
It absolutely could.
Sure.
To avoid one variable unfairly dominating just because of its scale,
Right.
Matchit offers something called scaled Euclidean distance.
Scaled Euclidean,
Okay.
where each variable is adjusted
Okay.
based on its variance.
So it's like we're putting everything on an equal footing,
Yeah,
making sure that a difference of 1 unit in GDP
right.
is treated proportionally to a difference of 1 percentage point in unemployment.
You got it. But there's still more to consider.
Oh, there is.
Yeah.
Yeah.
We also need to account for potential correlations between variables. For example, GDP and unemployment are often related.
Right.
If we don't account for this, we might be double counting their influence.
So it's like realizing that those two variables are telling us partly the same story,
Exactly.
and we don't want to overemphasize their impact.
And that's where Mahalanobis distance comes in.
Mahalanobis. Okay.
It's specifically designed to consider both the scale and the correlation between variables.
Okay.
It's like measuring distance on a map, but one that takes into account the hills and valleys,
The hills and valleys.
how the variables are related to each other.
I like that analogy.
And we can implement this directly in the Matchit function.
Okay, so how does Matchit actually go about finding these matches? Does it just like go down a list and grab the closest one
That's a good way to think about it.
based on our chosen distance measure?
Yeah, so when we use the method nearest argument, the function works in a greedy fashion.
Greedy matching.
It prioritizes finding the best match for each treated unit
Right.
at that moment.
Right. So it's like grabbing the closest cookie without worrying if there might be a better match for someone else later.
That's a fun way to put it.
Okay.
It's a fast approach, but there's also optimal matching,
Optimal matching.
which tries to find the best overall set of matches. We won't dive into that today,
Okay.
but it's good to know that it exists.
Okay, so I'm starting to grasp kind of the intricacies of distance matching. But you mentioned another approach earlier, weighting.
Right.
Can we talk about that?
Absolutely. Weighting is especially helpful when we have many variables,
Okay.
or we want to use our entire data set
Okay.
instead of discarding unmatched units. So instead of creating a perfectly matched sample, we adjust the importance of each unit based on its similarity to the treated group.
So we assign weights
Yeah.
to make the groups more comparable. This reminds me of propensity scores.
You're right on track.
Didn't we dive into those before?
We did. Propensity scores play a key role in many weighting techniques.
That's to refresh my memory. What exactly are propensity scores again?
So a propensity score represents the probability of a unit
Okay.
receiving treatment based on its observed characteristics.
Right.
In our case, it's like creating a score for how likely each clinic was to get the grant,
Right.
based on their political alignment, regardless of whether they actually received it.
So it's like quantifying how much each clinic resembles those that typically receive the grant.
Exactly. We can calculate these scores using statistical models like logistic regression.
Right.
Once we have those scores, we can use them to create weights for our analysis.
Okay, so if a clinic has a high propensity score, meaning it was very likely to get a grant anyway,
Right.
would we give it a lower weight in our analysis?
Yes, we downweight those units.
Okay.
Because they're already quite similar to
Yeah.
the treated group.
Okay.
Conversely, clinics with a low propensity score, those that were less likely to receive a grant, get higher weights
Okay.
to balance out the comparison.
So this is starting to click. So propensity scores help us create weights that essentially level the playing field
Exactly.
between our treated and control groups,
Yeah.
allowing us to use our entire data set
Yeah,
while still accounting for potential biases.
precisely. It's all about creating a more accurate representation
Right.
of the treatment's impact. Now, before we jump into the calculations, let's take a quick look at the distribution of these propensity scores.
Okay, what do you mean by distribution? Should we be looking for something specific?
So think about plotting a histogram
Okay.
of propensity scores for
Mhm.
both the treated and control groups.
Okay.
Ideally, we want to see a good amount of overlap between them,
Oh, yeah.
indicating that there are clinics in both groups
Right.
with similar probabilities of receiving the grant.
So it's like checking if there's enough common ground
Exactly.
between the groups to allow for a meaningful comparison.
Right. If they're completely separate,
Yeah.
it suggests our groups are just too different
Right.
to draw reliable conclusions.
What? Okay, now to evaluate how balanced our variables are before and after matching, the Match It package comes in handy again.
It does.
We can use the summary function
Right.
to compare the means and standard deviations of our matching variables in the original and matched datasets.
Yeah, and we can even visualize these distributions using a density plot to see the overlap.
Perfect. Okay, now I'm really curious about how those weights are actually calculated. Can we dive into
Of
that?
course. The formula for inverse probability weighting, or IPW,
IPW.
is fairly straightforward.
Okay.
Treated units, those that receive the grant,
Mm-hmm.
are given a weight of 1 divided by their propensity score.
Okay.
Untreated units receive a weight of 1 divided by 1 minus their propensity score.
Okay, so why this specific formula? What's the logic behind it?
It's all about balancing out the differences.
Okay.
Units that were less likely to be treated,
Mhm.
those with a low propensity score, are given higher weights
Right.
to make the groups more comparable.
Okay.
It's like giving a louder voice to those that might otherwise be overshadowed by the units that were more likely to be treated.
So we downplay the influence of the units that were already likely to be treated,
Mm-hmm.
while boosting the signal from those that were less likely. This is a very elegant approach.
It is. How do we use these weights in our analysis, though?
Right.
We simply incorporate them into our regression model.
Okay.
In our ways, we can specify the weights using the weights argument
Mm.
in the LM function.
Okay.
This way, instead of treating all units equally,
Right.
we give some units more weight than others based on their propensity scores,
Right.
helping us estimate the true impact of the treatment.
This is all coming together beautifully.
Yeah.
We've gone from exact matching to distance matching,
Mm-hmm.
and now to propensity scores and weighting. It's
Mhm.
like building this powerful toolkit for dealing with observational data.
You're catching on quickly. And the best part is,
that.
we can even combine these techniques.
Oh, we can.
Yeah, we could use propensity score matching to narrow down our sample and then apply weighting to further refine our analysis.
So it's not an either situation.
It's not. It depends on our research question
Right.
and the characteristics of our data.
So we can mix and match these techniques to get the most out of our data.
Exactly. The key is understanding the strengths and limitations of each approach.
Okay.
To illustrate this, I want to share a fascinating case study
All right.
about the impact of marijuana dispensaries on local outcomes,
Okay.
which utilizes these techniques in a real-world setting.
Perfect. I love case studies.
Yeah, it's a good one.
Let's dive into that in part 2.
Okay.
I'm ready to hear about this marijuana dispensary study.
All right, so this study was conducted by Conyers and Ayers in 2020,
Mm-hmm.
and they took advantage of a natural experiment in Arizona
Okay.
where medical marijuana dispensary licenses were allocated through a lottery system.
Ah, so some zip codes randomly ended up with dispensaries while others didn't, even if they had similar characteristics.
Exactly.
Sounds like a great opportunity to use propensity scores.
You're absolutely right. The researchers were able to calculate the probability of each zip code being allocated a dispensary based on those lottery results,
Okay.
and that became their propensity score.
So the propensity score is basically a measure of how lucky each zip code was in the dispensary lottery.
Yeah, you could think of it that way.
Did they just use these scores to create weights for their analysis?
Well, it was a bit more nuanced than that,
Yeah.
because some zip codes actually spanned multiple community health analysis areas,
Okay.
which were the units used for the lottery.
Wait, so a single zip code could have had multiple chances to win a dispensary?
Exactly, which meant their probability of getting at least one dispensary was higher.
Oh, okay.
So the researchers had to incorporate this into their propensity score calculations.
So they accounted for the fact that some zip codes had more entries in the lottery and were therefore more likely to win a dispensary.
Exactly. They had to make sure the propensity scores accurately reflected the true probability of getting a dispensary.
Gotcha. That's really clever. So then they used these propensity scores to create weights.
They did zip codes with lower probabilities of getting a dispensary. The unlucky ones were given higher weights.
So they were giving more weight to those zip codes that were less likely to have a dispensary, even if they did end up getting one because of the lottery.
Right. It helps to balance the comparison between zip codes that receive dispensaries and those that didn't, making the groups more comparable.
It's like adjusting the volume so we can hear from all the zip codes equally.
Exactly.
Okay, I'm seeing how this all ties together. So they essentially created this weighted sample where the weights reflect each zip code's chance of winning the dispensary lottery.
Mm-hmm.
But how did they actually use these weights to measure the impact of dispensaries?
They used a regression model to analyze various local outcomes, like property values, crime rates, and traffic accidents.
Oh.
But instead of treating all zip codes equally, they incorporated the weights to adjust for those differences in lottery probabilities.
So it sounds similar to the weighted regression we talked about earlier. But this time the weights come from those lottery-based propensity scores.
Exactly.
Did they find that dispensaries had a clear positive or negative impact on those outcomes?
The results were actually quite interesting because they were mixed.
Oh.
For some outcomes, like property values, they found no significant impact.
So no clear evidence that dispensaries caused property values to go up or down.
Exactly. But for other outcomes, like crime rates, the findings were a bit more nuanced and require further investigation.
That makes sense. It seems like the impact of dispensaries could depend on a variety of factors, and more research is needed to fully understand these complex relationships.
Absolutely. The real world is rarely black and white.
Right. This study provides a great example of how we can use techniques like propensity score weighting to tackle these real-world policy questions, especially when randomized controlled trials aren't an option.
I completely agree. It highlights the power of these methods in observational studies.
This case study highlights how powerful matching can be. But you mentioned earlier that matching has kind of fallen out of favor with some econometricians. Why is that?
So the main criticism of matching is that it relies primarily on observable variables.
Okay.
We're matching based on things we can measure.
Right, like the lottery probabilities in this dispensary study.
Exactly.
Or political ideology in our health clinic example.
Right.
But what about the things we can't easily measure?
That's precisely the concern. Those unobservable factors, what we call unobserved confounders, can still bias our results. And matching alone can't perfectly account for them.
So it's like we're matching based on what we can see. But there might be these hidden forces at play that we're missing.
Exactly.
And that's why some economists prefer techniques like difference in differences, which try to control for both observable and unobservable factors by looking at changes over time.
Right. We've talked about difference in differences before.
Yeah, we have.
On the deep dive, it's all about analyzing how outcomes change for both the treated and control groups before and after the treatment is introduced.
Right. While difference in differences has limitations.
Of course.
It's often considered more robust to those unobserved confounders.
It is. It attempts to account for those time-invariant unobservables that could be biasing our results.
So matching isn't inherently bad.
No, not at all.
But it's important to know its limitations.
Exactly. And we can even combine matching with other techniques to make our results even more reliable.
You can?
Yeah. For example, there are these things called doubly robust estimators that combine difference in differences with propensity score weighting, giving us the best of both worlds.
That sounds like a whole new level of econometric wizardry.
It can get pretty complex.
Yeah.
But the intuition is to leverage the strengths of both approaches.
That makes sense. But before we jump into those more complex techniques,
Sure.
I want to circle back to the dispensary study.
Okay.
You mentioned they used a regression model. Can you break down how they actually measured the impact of dispensaries?
Of course. Their regression model was set up in a really clever way. Almost like a modified version of difference in differences. So instead of just having a dispensary or no dispensary variable, they incorporated the number of dispensaries in each zip code.
So it's like measuring the intensity of the treatment.
Exactly.
A zip code with 3 dispensaries would have a stronger dose than one with just 1?
Precisely. And instead of a simple before and after variable, they used a continuous time variable that tracked the number of quarters since the dispensary lottery.
Oh, wow. So they were analyzing how those outcomes changed quarter by quarter after dispensaries were introduced.
Right. And of course, they incorporated those propensity score weights we talked about directly into their regression model.
That's right. The weights ensure that the comparisons between zip codes with and without dispensaries are as fair as possible. It's like accounting for those pre-existing differences that might have influenced both dispensary location and the local outcomes.
You've got it. This study provides a fantastic example of how researchers can use these techniques to address real-world policy evaluation challenges.
This has been a fantastic deep dive into matching. It's definitely given me a new appreciation for how powerful these techniques can be for working with observational data.
It's been a pleasure exploring this with you. Are you ready to wrap things up and leave our listeners with some final thoughts? Ready when you are.
Okay, so let's jump right back into that dispensary study.
Mm-hmm.
We left off talking about how they used a pretty creative regression model to measure the impact of dispensaries on those local outcomes.
Right. It was kind of a modified version of difference in differences.
Okay, and you mentioned that instead of just having a simple yes or no variable for whether a zip code got a dispensary,
Yeah.
they looked at the actual number of dispensaries.
Yep, exactly. It's
Yeah.
like we're measuring the intensity of the treatment, right?
Right, like a zip code with 3 dispensaries would have a much stronger dose than a zip code with just 1.
Precisely. And
Yeah.
then instead of using like a simple before and after variable,
Right.
they actually used a continuous time variable that tracked the number of quarters since that dispensary lottery.
So they could see those more nuanced trends as they play out over time.
Right. They're basically analyzing those trends quarter by quarter after those dispensaries were introduced.
Okay, and of course they incorporated those propensity score weights that we talked about
Mm-hmm.
to make sure that the comparisons between zip codes were fair.
Exactly.
It's really all about accounting for those pre-existing differences that might influence both where dispensaries were located and those local outcomes.
Right. We want to make sure we're comparing apples to apples.
Okay, so to the big question, did dispensaries have a positive or negative effect on those local outcomes?
Well, that's where things get a bit more interesting. The results were kind of a mixed bag.
Oh, really?
Yeah, so for some outcomes like property values,
Mm-hmm.
they really didn't find a significant impact.
So no clear evidence that dispensaries caused property values to rise or to fall.
Nope, not really. It seems like other factors were more important in driving those changes.
Okay, interesting. So not all outcomes were affected in the same way.
Right, and for other outcomes like crime rates,
Mm-hmm.
the findings were a bit more nuanced. They require more investigation. It wasn't a simple dispensaries are good or dispensaries are bad story.
Right, because the real world is rarely that simple.
It rarely is.
This is a great example of how economists use these sophisticated techniques
Yeah.
to try to untangle these complex policy questions.
It really highlights how powerful these methods can be for observational studies.
I'm so glad we took this deep dive into matching. I think it's really given me a new appreciation for the power of these techniques,
Me too.
especially when we're working with this kind of messy, real-world data where we can't always run those perfect randomized controlled trials.
Absolutely.
So as we wrap up, what are some key takeaways for our listeners?
Mm-hmm.
What do you hope they'll remember from this deep dive?
Well, I hope they'll remember that we can use these matching techniques to mimic random assignment even when we're dealing with observational data.
Yeah, it's like creating our own little controlled experiments
I love that analogy.
within the chaos of the real world.
It's a great way to think about it. It really highlights the power of these tools.
Yeah.
And I also hope our listeners remember that matching isn't a magic bullet. It has its limitations.
Right, especially when it comes to those unobservable factors we talked about.
Exactly. We always need to think critically about our data and consider different approaches,
Right.
like difference in differences,
Mm-hmm.
to make sure we're not missing anything.
Always a good reminder.
Hmm.
And I think maybe the biggest takeaway
Mm-hmm.
is that the world is complex,
It is.
and it rarely fits into these neat little categories.
That's for sure.
So I think it's through careful analysis and a healthy dose of skepticism that we can start to unravel those complexities and get closer to the truth.
Well said. I like that.
So to our listeners out there, keep those data minds engaged
Keep learning.
and never stop questioning the world around you.
That's what it's all about.
Thanks for joining us for this deep dive into matching and econometrics. We hope you learned something new, and we hope you're inspired to explore the fascinating world of data analysis.
It's been a pleasure. Until next time.